Hi, I'm Dr. Boaz and I'll be your guide during the course Introduction to Cognitive Psychology. When we test hearing, we conduct a study inside a sound attenuated booth, as you can see here. It makes sure that external sounds do not enter and internal sounds are absorbed by the wall. As you can see, when I placed the headphones on his head, I made sure that no external sounds would enter the ear, so only the sounds I make would be heard by the participant. I explained to the participant that there will be a range of sounds that he will hear. Some of them will be loud, some of them will be soft, some of them will be high tone, and some of them will be low tone. And his task is very simple, to press a button when he hears a tone. Some of the tones it is reasonable that he will hear, and some of the tones he will not be able to hear. In the class today, we'll learn about different ways to measure the threshold. The first one assumes that there is a threshold in the world. We assume that there is one point in the physical world above which we can sense everything, and below that point there is nothing. So we believe in a real threshold. It makes sense if you think about it, or maybe not. When we test it, we present stimuli that start very loud. We go weaker and weaker and weaker and weaker until the person cannot hear. And I can see his responses using this machine. The second method of limits, what I do is I start with the loudest, as you can see here, and I go weaker, you can still hear, weaker, you can still hear, weaker, you can still hear, until he cannot hear anymore. I stop and write. Then I go with the weakest point possible and start going louder, louder, and louder until I can hear. And I write that point. The average between the two will give me the threshold. Method of limits. We presented each intensity once to the participant. So 40, he heard. -5, no. -10, no. So we can say that our threshold is 0. That's the lowest point he could have heard. Now we can start from the weakest point and go louder and louder. So -10, no. -5, no. 5, yes. You may note that 0 is now no, but when we went down from 40, 0 was yes. He heard yes. Now we go 5, yes, 10, yes, and so on. So you can see that our threshold now is 5. We take the average between 5 and 0, and we have our threshold, which is a point between 0 and 5, 2.5. I just choose a very loud voice, and then randomly a low one, randomly another one, randomly another one, and I present these many, many, many times so I can calculate the average for each point and draw them on an Excel sheet. Each stimulus was presented 10 times to the participant, so we can now see what is the chance of that listener to hear the specific intensity. So at -10, 0, we'll go and draw 0 here. At -5, 2, so we had a 20% chance to hear it. So go here and draw 2. At 0, 4, 40%. We go at 0 and we draw 4. At 5, 7, 70%. We go here and draw 70. At 10, 9, 90%. We draw 9. At 15, 10, 100%. He always heard his chance was 100%. Whenever I presented 15, he always heard the stimuli. So I draw here, 15. Now I connect these dots and I am able to draw this kind of function. I go to the function and find the place for 50%. Note it is not a stimulus, that we ever presented to the participant. But we can calculate that this is the point of 50%. So any point above this point, his chances to hear the stimuli is above 50. Any point below, his chances to hear the stimuli are below 50%. So this will be our 50% threshold. To sum up, what we see in class today are 3 different methods to assess the threshold. The first 2 assume that there is a real threshold in the world, that there is a real point in the physical world above which you hear anything, below which you cannot hear anything. The third method have lost this naivety. She doesn't believe anymore that there is a real point. Instead, what we do is we calculate the statistical chances of hearing or of seeing or of smelling, I don't care. Statistical chances of feeling a physical stimuli. And on this beautiful function, we choose the point of 50% as the point above which your chances to hear are above 50, below which below 50. And this will be the point that we will calculate, that we'll use. But it's an artificial point. We have lost the belief that there is a real point. Now it's important to note, this is an amazing machine. I bought it for a reason, but it has limitation. For example, when we jump up and down in the level, we can jump by 5 decibels. That's not bad, but it's not the most accurate. When we manipulate the frequency, we can go up and down in jumps of 500, 1000, and sometimes 2000 hertz. When we will talk about this in class, it will be clear to you why it is reasonable in some ranges to jump in jumps of 2000 hertz, and in others you want to get down to 250 hertz. But still, 250 hertz is not as accurate as 50 hertz, or as 10 hertz, or as 1 hertz. That means that this machine has limitations. And the answer we get is limited by the abilities of this machine. We can never tell what is your threshold of hearing in 1050 hertz, only in 1000 hertz. Your take-home message. Your question dictates the tool you choose to test, and the tool dictates the type of answer you can get. When I say tool, it could be a machine like this, but it could also be the paradigm you use, the experimental paradigm. See you in class.